Is it clear?
Yeah.
Sure?
Yeah.
We'll now study the properties of y. Okay? Absolutely clear, friends? Now, so let me now understand what y does. First, let me find out whether the mean of yt is constant. First, I have to find out whether the mean of yt is constant. Right? Mean of yt. Do you think it will be constant? Do you think the mean of yt will constant? Do you think my average earnings, the average value of my earnings will keep on changing in time? That is right. See, yt is 5 yt minus 1 plus e.
Yeah.
This can be written as 5 by substituting for yt minus 1,
Yeah.
right?
Yes.
Sure?
Yes.
This is yeah? Is this clear? Everybody is getting this? Sure? Okay. This is what can I write this as? I can write it like this, right?
Yeah.
This will become 5 cube yt minus 3 okay. In general, if I do it j plus 1 times, I have done it say 3 times, I can do it 4, 5, 6. How many times I do it? I'll call it j plus 1. So I can write yt as, instead of t it will be
Yeah.
j plus 1, right? Instead of 3, so it's 3. So it's 3, it will be j plus 1.
Yeah.
Plus 5 raised to j et minus j plus 5 raised to j minus 1 et minus j minus 1. Yeah? Sure?
Yeah. Yeah.
Now what happens if j tends to infinity? Suppose the absolute value of 5 is less than 1. First let's think of the absolute value of 5 less than 1, and then which is not our random walk, and then try to see what will happen if 5 is equal to 1, which is the case of our random walk. Right? Sure, friends? Now when j tends to infinity, what is expectation yt? What is the absolute value of 5? We have first assumed to be less than 1 absolute value. So if you have something less than 1 absolute value, if you keep on raising it to higher and higher powers, what happens to that value? Say 0.7, if I keep on raising it to higher and higher powers, what will happen to the value? 0.7 square, 0.7 cube, 0.7 raised to 4 will keep on becoming 0. So if the absolute value of 5 is less than 1, this will tend to 0. Right?
Yeah.
Everybody gets this?
Yes.
Sure? But if so which will mean assuming the absolute value of 5 is less than 1, yt is 5 raised to j et minus j yeah? Sure? Assuming absolute value of 5 less than 1. Implies this. So it means expected of yt is,
So why doesn't 5 raised to j tend to 0 to?
it will be very close to 0. But we'll see that it doesn't really matter. Right? It doesn't, as you correctly said, you'll actually get 5 raised to j will also become very, very close to 0. Okay, but at the moment we just leave it because ultimately the answer is going to, it does not really going to matter in the answer. Right, so we have plus 5 raised to j expectation of et minus j minus 1 plus 5 raised to yeah? This is what expectation of yt is going to be. Now what is expectation of et? See, plus 1 minus 1, no? With equal probability 0.5, 0.5. So what is the expression of Et? 0. Similarly, Et minus 1 is the same variable at time period t minus 1. Et minus 1 is the same variable at time period t minus 2. So this expectation will be 0, this will be 0, this will be 0, all these will be 0. Right?
Therefore, your y2 is
Yeah.
0.
So expectation of Yt is equal to 0.
Yeah.
That's why it doesn't really matter what happens to these. Because expectation Yt is going to be 0. But this holds only if the absolute value of phi is less than 1.
Yeah.
If the absolute value of phi is equal to 1, then this quantity is not going to tend to 0. Right? So expectation Yt, if phi is equal to 1, then this is not going to be like this. You are going to get expected value of Yt will be
Phi j.
because this will be just this, and all these, of course, expected value Et's etc. are all 0.
Yeah.
Right? So this term is going to be always there.
So the expectation of
Expectation of Yt is just this, no? See, because phi is equal to 1. So Yt minus j plus 1 is the value of y at time period t minus j plus 1. Right? Yeah? You see what I've done? Sure? Because this would have been expectation of this, all those would be 0. Sure? Right? So what it means is, expectation of Yt then is some value of y at time period t minus j plus 1. The starting point, which depends upon time. So it fails the first condition for stationarity. It fails the first condition for stationarity. Okay, the remaining two conditions we'll see in the next class. Okay, so thank you very much.